as we get to some harder ones. Okay, here's our second graph. We're going to go right to a reflection problem. So if you notice, move the K in front here so you could see it. If it helps you, you could rewrite this as negative sine x plus 3 pi over 2 and put the 2 at the end. Okay? Yes, this one is reflected. It's got the negative. It has an amplitude of 1. The amplitude is the absolute value of A. It has a frequency of 1. B is your frequency, the number in front of the parentheses. The period is 2 pi over B. This is another one that's nice. It's 2 pi. It does have a horizontal shift. Plus is to the left, and it's left 1.5 pi, 3 pi over 2. And our vertical shift is up 2. So I'm going to do this one like I did the first one in the first way. I'm not going to do it without the shifts and then have it shift, okay? So sine starts at 0, 0. So first we're going to shift it left 1.5 pi. So I'm going to draw a new y-axis out here left 1.5 pi, and then up 2. Here is my new origin. So I put an X there so I remember. Notice it went from 0, 0 was right here. It's left 1.5 pi up 2. There's my shifts. Now I'm doing a sine function of 2 pi. So sine would start at the origin. And when you go over 2 pi, which is 8 spaces, everybody. Pi is 4 spaces, so I go over 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Pi starts at 0, ends at 0, and in the middle it's at 0. So those are 3 of my points. Now, that's my new x-axis, so I'm not going to flip those points, but I'm going to flip my amplitude here of 1. I would normally go up 1 and down 1, and that would be my graph. But this is a reflection, so I need to switch that up, and it starts at 0, 1, 2, we had a 0 here. I'm going to go halfway between, I'm going to go down 1, and then I'm going to go up. And there is your reflected graph. Remember, sine usually goes like this. So now I had to, instead of going up first, I went down. That's your reflection. So reflections are just kind of thinking about them and moving and picturing that graph all the time. Here's a good problem that has everything in it. It does not have a negative sign, so it is not reflected. Why did I put a y there? I have no idea. The amplitude is 3. There's A. B is 2. The period is 2 pi over B, which would be 2 pi over 2, which is pi. So that's a little bit different. The shift is to the right, 3 pi over 4, and down 1. So there's your K. Again, this one was nice. Everything was set up A, B, H, K. It's alphabetical. A amplitude, B for period and frequency, H for horizontal, K for vertical. So I'm going to do my shift right away. I'm going to go right 3/4 pi, make a new y-axis. I'm going to go down 1 and make a new x-axis. And I like to put an X there. Keeps me organized. That is where I'm going to start. Now I want to picture a sine wave. Starts at 0, 0, ends at 0, 0, all that kind of stuff. There's no flipping here, but my period is only pi. So I want to look at my scale. Pi is 4 spaces. 2 pi is 8 spaces across. So I'm going to start at 0, 0 because it's sine. I'm only going to go 4 spaces. My period is pi. So I'm stopping. And halfway in between there, what's sine do? It's back at 0, 0. All right, starts at 0, ends at 0, 0 in the middle. I think that terminology can help. Now the amplitude is 3, so halfway in between, from here, I go up 3. And I go down 3. And there is one cycle or one wave. I kind of missed that dot, sorry. Do a little bit better job here. Get rid of all the slop. So 1, 2, 3. 1, 2, 3. That's a little bit better. There's a sine graph with the shifts. Now we're going to flip a cosine. As you can probably see, this one is reflected because we have a negative A. So the amplitude is 3. Remember, the amplitude is the absolute value of A. B is 2. That means the period is 2 pi over B, which is another pi. Horizontal shift, this one has nothing in parentheses. We don't have to shift it horizontally. Yoo-hoo! And K is outside the parentheses, so K is +1 or up 1. All right, cosine. All I need to do, everybody, is move my x-axis up 1. Here is my new origin. Remember, I am going to flip this one. So cosine usually starts at its amplitude of 0, 3. This would be up here, but since it's flipped, I'm going to go down 3. So instead of it, cosine, I always think of it as it kind of makes a W. This one's going to make an M, all right? Here is 1 period. If you keep going, it kind of makes a W. So I'm going to start low. And that means I'm going to go a period of pi, which is 4 spaces. It's going to be down low again. Now what does it do in the middle? It goes up this time. And remember, if we are 3 below it, we got to go 3 above it. Then halfway in between are my x-intercepts. If you kept this going, you would see an M over there. So there is 1 period or 1 cycle. Notice it is starting down low instead of up high because these were reflected. These 2 points on the x-axis, they don't move. So we still have 2 x-intercepts. But what's down low goes up high. Reflections will make you think. Here's another sign. We're going to quick whip through it. It's got everything right here. It is not reflected. A is 2. B is 4. 2 pi over 4 is the same as 1/2 pi. This one is to the left pi. And this one is down 3. Now, if I were you, I would pause the video and see if you can do this. You have 2 choices. You could graph a normal sine function and then shift it left pi and down 3. But I'm going to do it our way, where we shift it right away. I'm going to go left pi, boom, minus pi. Down 3, negative 3. There's my new origin. Now I got the shift done. Plus, this really helps you think about how sine and cosine behave. So sine starts at 0, 0. And this one has a frequency, or an amplitude of 2, and a period of pi over 2. So I'm going to start at 0, 0. This is my new origin. And I'm only going to go over pi over 2. Well, pi over 2 is 2 spaces. There's the end. Sine starts at 0, ends at 0, and is 0 in the middle. So this one is the frequency is high, so that's going to squish my graph together. And now in between the zeros, I have to go up the amplitude of 2, so I go up 2 from here, and down 2 from the x-axis. And there's 1 cycle or 1 period. So I hope that helps you shifting around all these things. Now we're going to do the fun part where all we have to do is come up with the new equation given all of the shifts. So remember, amplitude, frequency and period, horizontal shift, vertical shift. So we're going to start off with a graph of y equals 1/2 cosine 6x. We are going to go up 8. That's a plus k. And we're going to go right 3. That's a minus h. So I'm going to add some parentheses and a number at the end. So I'm going to keep y equals. I'm going to keep 1/2. I'm going to keep cosine. I'm going to keep 6. But in parentheses, I'm going right 3. And then I'm going up 8. So this is asking you to take an equation and see if you can add the missing pieces. All right, so the next one, letter B, we are going translated left pi. So that's your h, and left is a plus. That would be a plus pi. And it's got a reflection. So all that does is throw a negative sign in there in front of the sign. So we would do y equals, instead of 6 sign, we would do negative 6 sign. We keep the 1/2, but in parentheses, we're going to put x plus pi. And our last one has some things going down. Up to is a plus k plus 2. And reflected over the line y equals 2, well, all we really need out of that is the word reflected. We know it was up to, so that's why I graphed those like I did. That means your new x-axis is up to, so that's where we're flipping it. So these 2 things are kind of telling you the same thing twice. If you need a picture of that, here is your normal x-axis. We're going up 2, so this is my new x-axis. All they're telling you is you're flipping it now on your new x-axis. So all I have to do to this problem is throw in a negative sign for the reflection, cosine pi, and I've got to put a plus 2, and I do not want it in parentheses. So there are some simple new equations. Now let's see if you can find the graph equation for both of these. And you've got to find a sine and a cosine equation. So what I would recommend is that you try to trace it. There are an infinite number of answers for both because you could start your wave wherever you want it. So let's take this slowly here. Let's start with sine. I'll do it in blue. So sine starts at 0, 0. I'm looking at this graph. A couple of things I can notice right away is that the amplitude is full. So that helps. And if I keep my x-axis in the same place with an amplitude of 4, I could start a sine wave shifted to the left one space. I could also start it at any of these x-intercepts. That's why there's a million answers. But I'm going to start at one that's close to 0, 0. And sine, remember, starts at 0, ends at 0, and is 0 in the middle. So I think tracing one wave is really important and really helpful. So my sine equation is going to be this blue equation. It could have been over here, it could have been here, it could have been here. You can reflect it if you want. You have so many options. But try to keep it simple at first and trace a wave. So in this wave, I've got an amplitude of 4. And take it one step at a time. Y equals A sine. My next letter is B. Okay, that's going to be the period. Well, I'm going to look at my wave here. I went 1, 2, 3, 4 spaces. 4 spaces means I have a period of pi. That means B is 2. Because 2 pi over B has to equal pi. If I put a 2 there, 2 divided by 2 is going to give me 1 pi. Then I'm going to do my shift to the right and to the left. I went to the left one space. One space is a 4th pi. Left is plus. So again, I'm reading everything from the graph. Here is my h. It was left 1/4 of pi. And my k is if I go up and down. This one did not. So you don't need the plus 0. I'm just there to emphasize it so that you can see your equation. That's hard. Now, let's do a cosine wave. So I'm going to do cosine in red. Everything stays the same. A cosine B, x minus h plus k. But it's a different wave in a different location. So I am going to retrace a cosine wave. And I'm going to start at 0, 4. Notice it is on the y-axis, so that's nice. There is no horizontal shift. And I'm going to end at pi 4. So this is nice. I still have an amplitude of 4. So it's the same. You're going to notice a few things here. Amplitudes won't change. If you see the period of the cosine is also pi. Whoops. I wrote 2 because that's what B is. Sorry. I'm trying to think ahead. If you look at my traced graph, it started at 0 and it ended at pi. Its distance was pi, and that's your period. So that means B is also 2 because the period of the sine wave was pi. Now this one has no vertical shift. There is no h because it started right here. So I don't have to put anything in parentheses. And this one started at 0, the amplitude. I did not have a vertical shift. So I want you to look at something. A stayed the same. B stayed the same. K stayed the same. When you do these equations, you guys, A, B, K are the same. The only thing you have to look for is the horizontal shift. This one, the sine wave was shifted over here. Put it back on here in blue so you can see it. This cosine wave wasn't shifted at all, so it did not have anything. So the only difference between the two equations is the h. We've got one